So welcome back. We'll start in part two this week with those three types of controls. The first we said was cybernetic control. Cybernetic control is by far really the most common, and it has a key feature in that it's automatic operations, right? It's about automating, right? The system is constantly being monitored. We're looking for deviations, and when we spot them, corrective action is taken. So these are, I wish, more common in projects, and I try to make them so. We have to monitor the system output, right? And the function is performed by sensors that measure one or more aspects of the output, presumably on those aspects that we wish to control. Measurements taken by a sensor are transmitted to something that compares them, and then the difference is sent to a decision maker, which will determine the corrective action. This picture is showing us that interaction right there. So, and the correction is often in various forms. Can be human, can be mechanistic, can be artificial intelligence, etc. Now, cybernetic control systems, these act to reduce the deviations from a standard, and that's called your negative feedback loop. So there are information requirements that go with it, right? So we must have a counteraction for every action, right? And it's not possible, it says, for complex systems. This may or may not be true. That's from the literature, from the readings, right? But we do need a strategy to aim the project manager in developing a control system. One such strategy is used to use is a cost-benefit analysis or cost-benefit approach, CBA, right? We may examine our work breakdown structures, which can tell us which of the project tasks are largely mechanistic, and so which offer themselves to a cybernetic control system. In IT around the network, we don't have sensors everywhere in the network, but we've got sensors on key nodes that send data to a collector, and in the collector then we analyze the data and take the appropriate action. So, but those are mechanistic options, right? And so that's how we can do that. So perhaps the most difficult task in creating the cybernetic control system is setting the standard that you want to look for. These standards are a common subject when negotiating between interested parties, between me and a vendor perhaps, right? And so we're looking for a critical ratio, which we'll talk about shortly, earned value analysis, which we've already addressed, and they can both be parts of cybernetic control. For example, the cost and schedule variances, SPI and CPI, that we've already talked about earlier, can be entered as standards, and specific deviations from the cost performance index or schedule performance index can be used to trigger your project manager's review and correction as necessary. Now, the next type of control is a go, no-go. Go, no-go controls take the form of testing to see if some specific precondition has been met. We test all the time. In fact, the most common inspection tool, the most common tool in quality is the tool called inspection. So we're looking to see if some precondition has been met. So the project plan, the budget, the schedule, these are all control documents, and the project manager will design then a control system complete with pre-specified milestones as natural checkpoints, right? So we're comparing these baselines, the plan, budget, and schedule. Those are control documents, our project baselines, to milestones as natural checkpoint, right? In quality management, we might also do attribute sampling. It's a simple yes or no. Does it meet the requirements for which it was being built, right? We could have a measurement for the quality degree, right? If it's not yes or no, right? What does it take to meet the requirements? So these controls basically should be linked to the actual plans, right? So that's why I tie it to the baselines. That's part of our project plan. These controls should be linked to the actual plan and the occurrence of real events, and those are the milestones. Not simply tied to some calendar, right? To an event, a milestone. And so we want to constantly monitor the baselines, but particularly around the milestones. The project manager must keep abreast of all aspects of the project and follow up. And we want to establish then some sort of early warning system as part of this. The most important rule for any subordinate is the prime law of life on a project. And that's this: never let the boss be surprised. That's the prime law of life. Controls have a tendency to terrorize insecure people, and they can induce high anxiety in everyone else. The result is avoidance, and an avoidance is exactly what the project manager cannot tolerate, right? So a corollary to this prime law of life, that never let the boss be surprised, is the corollary, which is always think 2 levels above yourself when you're thinking in terms of controls. What would they say at a level above yourself, which would be your boss, or 2 levels, your boss's boss? Think like them, right? So in these go, no-go controls, this is one form, and it's very popular, and it's frankly this phase-gated process. It goes by various other names. Stage gates, toll gates, quality gates, kill points, etc. But it's a phased gated process. And you'll do this at various points throughout the project life cycle. I frankly do it at the end of each project phase. So these series of gates or checks are planned. And this is where I might do Lean Six Sigma, which includes define, measure, analyze, improve, and control methodology, right? That's frankly their Deming's approach, Six Sigma's Deming's approach to plan, do, check, act. Six Sigma calls it define, measure, analyze, improve, control. So I might do this in each of the 5 phases, and that is going to serve as my project milestones. So I'm tying now my milestones to the end of each project phase, which in turn is frequently used as a toll gate for the next phase. I'll give you a picture of that. This was a slide we had earlier in the course, and it's just kind of a review of the life cycle, the process. So all 3 of these phases would be part of my life cycle. And notice at the end of the project, phase 1 on the left, I'll do a gate check, a phase gate, before I go on to the next phase. And in the middle phase, I will do a phase check in closing before going on to the final phase. And in that phase, I'll do a phase check to make sure my project is complete. So the project then becomes more predictive, but yet at the same time, it's iterative or incremental, right? We're proceeding along the way. To do this properly, we talked about comparing at the baselines at milestones, and we talked about comparing the plan versus the actual, right? So the plan is what we built in advance. The actual data starts with work performance data. I think this is kind of a review of what we've discussed earlier. Work performance data is raw data. While I'm building it, I'm collecting data. And you'll say to your project managers, what data have you collected? And then have you analyzed that data? We call that work performance information. And that's something we use a lot in controlling. Because what it says is work performance information, I've analyzed the data. What it says is I've looked at my plan and I've looked at my data and I've analyzed the two. And then the final one is work performance reports. These are your data that's been analyzed, compiled into some one-page report that you could pass to your boss or other stakeholders and get their insights. They don't have to read all the data or analyze it themselves. You've done that in a report, and that also adds to your control capability. And so as a result then, we have this information requirements for this go, no, go, and that was that work performance data, work performance information, work performance reports. Those are going to lead to status reports, which are a great way to communicate in control. Now in post-control, these things can be applied after the fact, right? Lessons learned, historical documents, organizational process assets that we update, right? It is a full recognition of George Santanayan's observation that those who cannot remember the past are condemned to repeat it. So it's directed towards improving the chances of future projects, right? So changes in project management methods can result from your suggested changes. And that's a post-control capability. We said we were going to talk about cybernetic control, phase, gate, or go, no-go controls, and post-control. So in post-control, notice that even though we said lessons learned, notice on this chart, these are kind of your process groups in project management: the initiating, planning, executing, monitoring, and controlling, which is where we're at now, and closing. Notice in closing on the far right, LL, that's lessons learned. That's really a function of closing out each phase or each project, right? On those circles, those phases I showed you. But notice I'm actually collecting, if you look in the bottom line, lessons learned throughout the entire project. I'm actually identifying stakeholders throughout the entire project, even though I do it in initiating. I'm actually team building throughout the entire project. I'm actually managing all the stakeholders and assessing risks throughout the entire project. But I'm also doing lessons learned throughout the entire project. So I can then ensure that I do post-report as appropriate based on my milestones, my gates, my budget items, etc. Whatever is needed to improve, right? These become key to closing a phase or a project, right? We want to show kind of a summary slide of where we're at, of the project reports. Now then we move into the design of the control systems, right? So irrespective of the type of control that we use, of the three we just talked about, there are some important questions to be answered when designing any control system. Like, who sets the standards? Will they achieve the project's goals, etc.? Are the standards clear? There are many more than are listed here. These are just kind of some examples. Even who should take action, right? So in addition to being sensible, a good control system also possesses some other characteristics, right? It should be flexible. It should be cost effective. It should be useful. It should satisfy the needs of the stakeholders and hence of the project. It should be ethical and timely, right? We talked about sensors in a control system and putting those out there. And are they accurate? And are they precise, right? Quality control terms. Accurate means you hit the center of the target, and precise means all the dots are hitting together, right? They're not all spread out. And are we fully documenting it, right? So no matter how well it's designed, all control systems need a feedback mechanism. And the control of cost, scope, and schedule usually requires input from various data. And so we will pick up with that in the next and final section for this week.